Hey there, everybody. Okay, so in this video, we're going to kind of motivate your journal for this week, which is why is it that a negative number times a negative number is a positive? Why does it make sense that a negative number times a negative number is a positive number? And I want to use something we used in class last week, or this week, I guess, it's Friday right now, to kind of drive this point home. So what I want to look at is, I want to look at a simple multiplication problem. Let's do 6 times 4, which you know is 24. Now, one way you can look at 6 times 4 is 24, and we did this in class with different numbers, is you can view the 6 as one dimension of a rectangle, and then the 4 as the perpendicular one. And you can say that's 6, and this is 4, and then the whole area of the rectangle is 24 square units. If this is 6 units and that's 4 units, it's 24 square units. And that's, I'm sure at some point in your math careers you learned that. But what you can also do is you can break up these numbers into other pieces. For example, if I may, let's take the 6 and let's make it 3 plus 3. And then do that first by putting it in parentheses and then multiplying it by 4. Now you know by order of operations it's still going to be 6 times 4, which is 24. But if you look at it in a rectangular way, it's going to be the same big size rectangle. But instead of having the 6 go all the way across the top, we can break it into 2 3s and then have this 4 here. And then we can do the individual, I'm going to get that dotted actually. We can do the individual areas of these little pieces. 3 times 4 is 12. 3 times 4 is 12. And then these two 12s added together give us the same thing as that 24. So it's literally just a way of breaking up the rectangle into smaller pieces. Look at it in a different way. We could even break both numbers up, right? You could break up, we could make this one 4 plus 2 to make 6, and we can make this one 3 plus 1 to make 4. Okay, still going to be 24, order of operations, 6 times 4. But then the rectangle would be broken up into, I think, 4 pieces, yeah? Because if you're breaking this up into 3 plus 1, this would be 3 and this would be 1. And then 4 plus 2 would look something like this. That's 4 and that's 2. Okay, so you got a 4 times 3 is 12. 4 times 1 is 4. 2 times 3 is 6. And 2 times 1 is 2. And if you add all these up, 12 plus 6 plus 2 plus 4, you get 24 again. So it's really just a way of kind of breaking up the rectangle that represents the product of the two numbers into pieces. And you can get really crazy. I mean, you could probably, do something like, 2 plus 2 plus 2 times 1 plus 1 plus 1 plus 1, which is great and all, but I mean, it gets a little ridiculous at that point. And that's not what I wanted to get at. I didn't want to get at making it as convoluted as possible. What I wanted to do now is I want to bring negative numbers in. Now, I don't want you to think about a negative number as a length, because that doesn't make any sense. I want you to realize that a negative number, or a number, well, I'm going to get ahead of myself. I'm going to stop myself right there. Original problem is 6 times 4. Okay. 6 times 4, we could write this as 7 minus 1 times 4. Couldn't we? Yes, we could. 7 minus 1 times 4. And we agreed this past week that subtracting a positive is the same as adding a negative, which means you could think of this as 7 plus a negative 1 times 4. Now what I'm going to do is, I'm going to draw that rectangle again. And it's going to look a little bit weird geometrically, but I'm just going to write this side in 2 pieces. The 7 piece and the negative 1 piece. Take these out. So this is the 7 piece, and that's the negative 1 piece. Add these together, boom, plus that, you're going to get 6. I know technically the negative should be like working backwards, but don't worry about that. Just worry about the value is negative. And 7 plus negative 1 is 6. I'm going to leave this as 4. Now what you can think of is this 4 times this 7 is 28. And we already agreed in class last time that 4 negative 1s are negative 4. And if you add 28 plus negative 4, you get 28 minus 4, which is 24, which is exactly what we know 6 times 4 is. So if you want to view it, anything with a negative area, right, with a negative, like a negative 4 like this, would be like a negative area. You'd have to take that away from this area if you needed to visualize it as a negative. Okay, so far? We could also, again, get very, very convoluted like this. Let's write it, instead of 7 minus 1 times 4, let's keep 7 minus 1. But make 4 3 plus 1, 3 plus 1. Okay, so kind of like do it on the other side, kind of the same thing. I'm going to use the same rectangle. Okay, I'm going to drop this line in here. 7 minus 1, it's going to be the same as this one. I'll put it in parentheses if that helps. And then 3 plus 1, and you got 3 and plus 1. And then we're just going to do the multiplications. 7 times 3 is 21. 7 times 1 is 7. 3 times negative 1 is negative 3. And 1 times negative 1 is negative 1. And you're going to see pretty quickly what's going to happen. 21 plus 7 is 28. Minus 3 is 25. Minus 1 is 24. So once again, you end up with the exact same 24. You're adding the negative values in, and that's bringing it back down to what it should be at 24. Okay. Now here's where I think we can explain to ourselves why negative times negative is a positive, at least why it makes sense mathematically. I'm a big fan of using a rule, or using as few rules as possible, but using those rules in every possible application. So what we're going to do is we're going to leave that original problem on board, because we know it's equal to 24. But what I want you to do is I want you to complete these problems for me. And this is going to be our journal discussion this week. Okay. So instead of writing it as 6 times 4, we're going to write it as 7 minus 1 times 5 minus 1. Now, order of operations says 7 minus 1 is 6, 5 minus 1 is 4, and that's supposed to be 24. Like, we know mathematically it's 24. But what I'm going to do is I want to view this as a geometry problem. Like this. I want to view it like a geometry problem like this. So what we're going to do is we're going to draw ourselves a rectangle. Okay, and I'm going to draw in some dotted lines to separate the plus signs. Okay, and I'm going to add in this 7, negative 1, 5, negative 1. Here's what I want you to do. I want you to tell me, and I'm going to label these. We'll make it one problem. I'm going to label these areas A, B, C, and D. Now, if you think about all the other problems we did today so far, today being the past 10 minutes, when we got to this point, we were able to do boom times boom equals boom, boom times boom equals boom, boom times boom equals boom, and boom times boom equals boom. And then we were able to say that A plus B plus C plus D equal 24. So we know they all have to add up to 24. Here's your job. Your job is to figure out the values of A, B, C, and D. I'm going to tell you this right now. This is what I think is going to make an interesting journal. 3 of them you're going to get like that because we've already talked about them. The 4th one, you're going to hit it and you're going to go, okay, I think I know what that one has to be. What I want you to write about in your journal this week is not just tell me what the last one is, but tell me why, under this, why it has to be that and can't be its opposite. Okay? So when you get to that last area that's gonna feel weird, because it's not gonna feel like it fits the other logic of multiplication, you're gonna realize that because this plus this plus this plus this has to be 24, that last thing has to be something to make it work. Okay? So that's what I want you to journal about this week. I want you to journal about how this example helps us come to peace with why a negative times a negative is a positive. Cool? Makes sense? I hope so. If not, you can always send me emails, stop by in class, talk to me in class, and we'll figure it out. But hope that makes sense. We'll catch you next week.